Connecting a computer to the network requires a network interface card connected to the appropriate network medium. This creates the physical connection to the network. In addition, the computer must be configured to use the protocols that match the protocols used on the network. In this video, we'll look at the configuration parameters required to connect to a TCP/IP network. Be aware that for many networks, configuration is done automatically. Most network cards are enabled automatically, and the computers are configured to use TCP/IP and receive configuration information from a central server. With DHCP, or the Dynamic Host Configuration Protocol, you can configure a central server, and as devices connect to that server, they receive that addressing and other configuration information from the DHCP server. In this case, you simply connect the computer to the network, and it automatically configures itself. The configuration parameters we will look at are those parameters that can be configured automatically, or in some cases may need to be configured manually. For example, if you're connecting to a small network that does not have the services for providing automatic configuration. The first parameter we'll look at is the IP address. The IP address uniquely identifies every host on the network. An IP address is composed of 4 numbers separated by periods. Each number group is called an octet. Each octet can range between 0 and 255. So for example, a common IP address might be 192.168.1.15. For computers, you need to identify the host address along with a subnet address. A subnet is a segment of the network that has the same subnet or network address. All of the devices on this subnet share the same subnet address, even though they have different host addresses. Both pieces of this information for a computer are contained within the IP address. The computer separates the subnet address from the host address using a special value called a subnet mask. The job of the subnet mask is to simply divide the address into its 2 different components. Subnet mask looks something like this: 255.255.255.0. In this case, any octet which has a value of 255 identifies an octet that is part of the subnet address. So in this case, I have a subnet address that occupies the left 3 octets. So the subnet address would be 192.168.1.0 for the subnet address. Everything past the mask is set to 0 for the subnet address. The host address is then anything to the right of the subnet mask. In this case, the host address would be 15. Computers use the IP address to communicate with other computers. The IP address uniquely identifies each computer on the network. When you configure the IP address for a computer, there are a few things you need to be aware of. In this example, let's assume that we have an existing network. And because I already have an existing network with an existing host on it, I've looked at the IP address that's assigned to this host on the network. And I might find something like this: 10.1.6.122. as its IP address, and for its subnet mask, I might see 255.0.0.0. If I were to connect a separate host to the same network, I need to follow some simple rules. First, the subnet address used by this host must match the subnet address used by all other hosts on the same subnet. So in this case, because of the mask value, I know that the subnet used is 10.0.0.0. So when I'm assigning an address to this host, it must begin with 10, and at that point it can be followed by any other number. The second rule I have to follow is that all hosts on the same subnet must use the same mask value. So in this case, this host would get the mask value of 255.0.0.0. If I used a different mask value, this computer might think it's on a different subnet than this computer. The third rule I need to follow is that all hosts on the subnet must have a unique host portion of the address. In this case, this host is assigned the host ID of 1.6.122. In this example, I have a wide range of numbers I can assign to this new host without conflicting with the IP address used by this host. If I only had these two hosts on my network, the only criteria I would have to remember is don't use this exact same address, use something else. So for instance, I'll use 10.0.0.1. Another rule I need to follow is I can't use the subnet address when assigning to a host. So we've already identified the subnet address as 10.0.0.0. In other words, I simply can't use the first address that's possible in this host portion of the address, which is 0. And the final rule is I cannot use the last possible address in this range. And the last address is found by setting each octet to 255. So in this case, I could not assign this host the address of 10.255.255.255. Configuring the IP address and the subnet mask allows a computer to communicate with other devices on the same subnet. If you stopped your configuration here, the device could communicate with other devices on the same subnet, but would not be able to communicate with computers on other subnets or the internet. To allow a host to communicate with computers on different subnets, you must define the default gateway address. The default gateway address identifies a router that is used for sending packets to other networks. A router is a device with two or more network interface cards. Each network interface card is connected to a separate subnet. For example, this subnet might use an address of 192.168.1.0 with a mask of 255.255.255.0, while this subnet uses an address of 192.168.2.0 with the same mask value. For hosts on this network, when a computer has a message to send, the first thing that it does is it looks at the destination address of the other computer. Let's say in this case, I had a message that I needed to send to the computer that has the host address ending in .15 on this same subnet. The sending device would check the destination address, realize that the address is on its same subnet, and simply send that information to the destination computer. If, on the other hand, the destination were to a different device on a different subnet, for instance 192.168.2.25, the sending device would check the destination address, realize that it's on a different subnet, and in that case it would have to send the message to the router. The router could then forward that packet on to the destination device. The default gateway is an IP address configured on each computer that identifies the router to use when sending messages to subnets outside of its own local subnet. In this case, this router has two separate interfaces connected to two separate networks. This interface would have an IP address assigned on this subnet, for example 192.168.1.1. This interface is also configured with an IP address that connects to this network, for example 192.168.2.1. For all computers on this subnet, I need to configure the default gateway value that points to the router interface closest or on the same subnet as the computer. So on this computer, I would need to identify 192.168.1.1 as the default gateway. And I would do that on every single computer connected to this subnet. When configuring the default gateway, don't configure this address as the default gateway address, because the computer would look at that address and say, that's not on my subnet, I can't talk to that device. So the default gateway needs to be on the same subnet as the computer's address as well. Likewise, in this subnet, this computer would need to have a default gateway value of the router, which would be the IP address closest to it on its same subnet. In this case, the 192.168.2.1 address. In a typical home scenario, I might replace this destination network here with a connection to the internet. In this example, by configuring the default gateway on this computer, I can allow this computer now to access hosts on the internet. Again, packets for hosts on the internet are sent through the default gateway out to the internet. If you've connected your network to the Internet and configured each host with an IP address, subnet mask, and default gateway address, then your computer can talk to other devices on the network. Remember that computers use IP addresses to communicate with other devices. If you stopped your configuration at this point, you would have to memorize the IP address of every computer on the Internet that you want to communicate with. For example, if you were browsing the Internet, you would have to memorize the IP address of every website you wanted to visit. Instead of using IP addresses, you are using logical names to identify destination computers. Logical names are easier for you to remember, but the computer must translate the names you provide into IP addresses. The computer does this using a system called the Domain Name System, or DNS. With DNS, a special server called the DNS server is configured with the host name and IP address of many different computers. So, for example, if I'm working at a computer and I want to visit the website www.comptia.org, my computer would ask the DNS server for the IP address that matches the name that I give it. The DNS server would then reply with the IP address, and the computer would then use the IP address to communicate directly with that computer. So when I configure my computer with a network connection, I need to identify the IP address of a DNS server that the computer can use to resolve the name into an IP address that it can use. Now, one rule about the DNS address that I specify on my computer is that it does not have to be on the same subnet as this device. It really depends on where the computer is. I can have, for example, a network that connects my computer with a DNS server on the same subnet. In that case, the IP address of the DNS server just happens to be on the same subnet as this host. A typical implementation, however, for DNS uses a router to connect my network to an ISP, which is then connected to the Internet. When I have a name that I need to resolve, my computer communicates with the DNS server at the ISP to get the name. And in this case, the DNS server is on a completely different subnet from my computer. So the only important thing is that the computer have an address of a DNS server that it can contact, so that when I use names, the computer can find the IP address for the host on the network. One other configuration parameter that you should be aware of is the host name. This is a logical name for your computer. You can configure your computer with a name that other users can use to identify and connect to your computer. Configuring a host name for your computer is not a requirement for connecting to the Internet, because devices on the Internet typically do not contact your computer directly. They may respond to requests that you have sent out, but in that case they respond using your IP address and not a logical name. Host names are typically used within a business to identify computers on your own local area network. You may also use a host name if your computer were connected to the Internet and providing a service. For example, if you wanted to have a web server on the Internet, you would assign a host name to that device so that users could find and connect to your computer using the name instead of the IP address.